Scanning electron microscope is one of the most useful instruments in research today. Scanning electron microscope, known as SEM, uses electrons instead of light to form an image, and it allows researchers to examine a bigger variety of specimens. In 1930, Manfred von Ardeen, a German researcher and applied physicist, invented a true microscope with high magnification by scanning a very small raster with a focused electron beam.
What is special about SEM is it can enlarge organisms from a microscope and use the scanning coils to create a magnetic field, using punctuating voltage to manipulate the electron beam. Just like in this picture, the glomerulum of the mouse kidney is showing that as a broken capillary.
If a researcher wants to increase the magnification of the butterfly wing, he or she simply sets the electron beam to a scan smaller area of the sample. The electron beam is scanned in a raster pattern over the surface for imaging.
The most important thing to know about scanning electron microscope is how it works.
A beam of electrons is generated in the electron gun, located at the top of the column where the filament is located. A voltage is applied to the loop, causing it to heat up. The anode forms powerful attractive forces for the electron. This causes electrons to accelerate towards the anode. The beam passes through the condenser lens, then through the scanning coil, and focuses a very fine point in the sample by the objective lens.
SEM has benefits that we have to know. The higher resolution, three-dimensional images produced by SEMs provide topographical, morphological, and compositional information makes them invaluable in the variety of science and industry applications.
The limitations of SEM are that samples must be solid and they must fit into the microscope chamber. The maximum size in horizontal dimensions is on the order of 10 cm, and in the vertical dimensions is 40 mm. The requirements for SEMs needed to run are power supply, vacuum system, cooling system, vibration-free floor, and room free for ambient magnetic and electric fields. In every scientific instrument, there are lots of safety concerns like to warn workers of the risk of interfering with any safety devices because an investigator needs to have permission to override any interlocks or warning devices. Scanning electron microscope is normally around $200,000. You can get the cheaper and simpler alternative for $72,000.